Next we discuss few book back questions and an additional question also. So first questions, what is mean by power of accommodation of eye? The ability of the eye lens to adjust its focal length to clearly focus rays coming from distant as well as near objects on the retina is called the power of accommodation of the eye. That means we can see the nearby object, that is any book we can read it, and also we have to see the far away objects, any persons is walking on the road. Both the object can easily focus our eye lens with the help of ciliary muscles. This ability of the eye lens is called the power of accommodation of the eye. Second questions, a person with a myopic eye cannot see objects beyond 1.2 meter, that is 120 centimeter distinctly. What should be the type of the corrective lens used to restore proper vision? A person cannot see the far away object, but he can see the nearby object because he cannot see the object beyond 120 centimeter. The defect is myopia. So this defect can be corrected by using concave lens. And the third question is, what is forepoint and near point of the human eye with normal vision? So a person can see the minimum distance, that distance is the near point of the eye. For normal human eye, the distance is about 25 centimeter. So we can see the nearby object from 25 centimeter, but we could not see before 25 centimeter. And a person can see the far away objects which is at infinity. The far point of the normal human eye is infinity. So because he can able to see the object which is at infinity. The range of near point and far point for human eye are 25 centimeter to infinity. The fourth question, a student has difficulty reading the blackboard while sitting in the last row. He could not be able to see the far away object. What would be the defect the child is suffering from? So how can be corrected? So the defect is myopia. This defect can be corrected by using concave lens, that means diverging lens. Next we discussed an additional questions and answers. First questions, why does it take sometimes to see the object in dim light when you enter the room from bright sunlight outside? For example, in summer season, the outside of our home is too bright. Let us consider our room will be dark. There is no light in the room. In that situations, in bright sunlight, the iris contracts the pupil to allow less light to enter the eye, because we are in outside the home, more amount of light entering our eye, but the iris contracts the pupil to allow the less amount of light to enter the eye. After entering into our home, there is no light. So in dim light, the iris expands the pupil to admit more amount of light to see the object clearly. Therefore, iris takes sometimes to increase the size of the pupil in dim room. It may appear darkness in our room. We could not see any object in the room. And the next questions, why are we not able to see the things clearly? We come out of the dark room. It's just opposite to the previous case. So we are exit from the theater. In cinema theater, there is less amount of light, so the people admit more amount of light to see the object clearly. But we come out of the theater, that means dark room, into bright sunlight. That means we come out of out from the theater into outside of the theaters. So there is more amount of sunlight. So the large amount of light enter into our eyes, and due to glare feeling, we are not able to see the things clearly. Gradually, the iris contracts the pupils to allow less amount of light enter the eye to see the object clearly. It takes some time for the pupil. For that time interval, person is not able to see the things. The next question. A glass prism is able to produce a spectrum when white light passes through it, but glass slab does not produce any spectrum. Explain why is it so? For prism or dispersion, the two refracting surface should not be parallel. In prism, no two refracting surfaces are parallel. When they are parallel, the light undergo only lateral displacement and emerge parallel to the incident ray. So this concept is already discussed in glass slab, because glass slab produce lateral displacement. That means the distance between the incident ray and emergent ray, that gap is called lateral displacement. But in these situations, the emergence ray and incident ray are parallel to each other. This is to fact that rectangular glass slab can consider as equivalent of two identical glass prism in inverted positions with respect to each other. So we can join the two identical prism. We can form the rectangular glass slab. In glass slab, the deviation and dispersions produced by the second inverted prism are equal and opposite to the produced by the first prism. In the situations, we can join two prism. We can form a glass slab. So the first prism is produce the dispersion. So white light is dispersed and then forms 7 colors. And these 7 colors are recombined by the second prism. So we get the white light. We get lateral displacement. We could not get a dispersion of light in glass slab. So next questions. Why do observe random wavering or flicking of the objects near a fire or on very hot day on the road? That means mirage. So this is due to atmospheric refractions. The air just above the fire on very hot day becomes very hot. So the hot air is a light-weighted and cold air is a denser. So it has a more weight compared than hot air. So the hot air goes up, the cooler air comes down. Atmosphere has a different refractive index. Hotter air has a less refractive index than colder air. Colder air comes down and hotter air goes up. Since the physical condition of air varies continuously, the apparent position of the object as seen through the hot air fluctuate. These fluctuate from wavering or flickering of the objects. Hence, the atmospheric refractions is the basic cause for observing random wavering or flickering of the object near a fire or on very hot day. And the last questions. State the factors on which the color of the scattered light preserved by us depends. The color of the scattered light preserved by us depends upon the size of the particles. That is, first one, very finite particles, that is gas particles, gas molecules, scattered mainly blue color, that means shorter wavelength. And the large sized particles scatter the light of longer wavelength, that means water vapors and dust particles. And the next one, enough large particles scatter the light which appears white, that means water droplets, I think cloud act as large particles. So after entering the light from the cloud, it appears white light. There is no changing color of the sunlight.